So, the first question, with a change in hybridization of the carbon bearing the charge, the stability of the carbanion increases in order. So first of all, we need to know that the stability of carbanion increases with increase in S character of hybrid orbitals of the carbon bearing charge. Now in sp3, the percentage of S is 25%. In sp2, the percentage of S character is 33.33%. And in sp hybridization, the percentage of S character is 50%. So this is how the stability of carbanion increases. That means sp will have the highest, then sp2, and sp3 will have the lowest. So the correct answer among the given option is option C, that sp3 has the lowest, then sp2, and then sp. The correct answer is option C. Next question. Which of the following compounds are not arranged in order of decreasing reactivity towards electrophilic substitution? Now we know this is a fluorobenzene, chlorobenzene, bromobenzene. So here the halogen groups are attached. Next, phenol, N-propylbenzene, and benzoic acid. So here we have R groups attached, and here it is COH group. Okay. Next is chlorotoluene, paranitrotoluene, and 2-chloro-4-nitrotoluene. And the last is benzoic acid, phenol, and N-propylbenzene. So the not arranged in the correct order of decreasing reactivity is option D, because the benzoic acid, that is this COH group, is deactivating group. Hence the benzoic acid is very less reactive towards the electrophilic substitution than that of phenol. So this is not correct. This was correct. Phenol is more reactive than benzoic acid, and you have N-propylbenzene in between there. Rest all the options are correct, but this option D is not properly arranged according to the decreasing reactivity towards electrophilic substitution. So the correct answer is option D. Next question. SN1 reaction is faster in. So first of all, this term SN1 stands for substitution nucleophilic, and this one stands for unimolecular reaction. Now we know that SN1 mechanism is a two-step mechanism, where in the first step the generation of carbocation takes place, and in the second step the carbocation reacts with another group to make the product. So SN1 mechanism proceeds through this carbocation intermediate and provides stable carbocation intermediate is the group which is SN1 reaction is faster in. So the correct answer among the given option is this tertiary butyl chloride. Okay. Now this tertiary butyl chloride will react very faster in this SN1 reaction. Why? Because when this chlorine will remove out, this carbon will generate a tertiary carbocation, and the stability of carbocation is in the order tertiary, secondary, and then primary. So among the given option, only tertiary carbocation generation group is possible in this one. Here you can get a secondary, here you can get a primary, and here you can get a secondary carbocation. So correct answer among the given options is option C. Next question. How many enantiomer pairs are obtained by monochlorination of 2,3 dimethyl butane. So first of all, we are supposed to make this 4 carbon chain where there is 2 methyl group present at second and the third position. Rest all hydrogen valencies. Now the monochlorination can take place either on this carbon or on this carbon or on this carbon or on this carbon. Now this molecule is completely symmetrical. Wherever the monochlorination take place, the product will be absolutely same. So we'll do the monochlorination on this carbon and we'll see what the product is formed, that is CH3, CH, this CH3, this CH, and this CH3 will remain as it is, and this CH3 will convert after monochlorination into CH2Cl. Now if we look at this carbon has become chiral now. This carbon is attached with one isopropyl group here, one methyl group, one hydrogen and one CH2Cl group. So this chiral carbon, due to the presence of this chiral carbon, it shows the optical activity and its mirror image are non-superimposable. So it shows one enantiomeric pair, that means 2 mirror images. So the correct answer among the given option is option E, that is 1 enantiomeric pairs are obtained. Last question. Among the following compound 1, 2 and this 3, the correct order of reaction with electrophilic reagent is, now this 1 is methoxy group, OCH3, that is methoxy group, anisole. This is benzene with no group and this is NO2 with a nitro group. We know methoxy group is electron releasing and it increases electron density of benzene nucleus, while this NO2 is electron donating group and it decreases electron density on the benzene. So because of that, the correct order of reaction with electrophilic reagent is first, that is methoxybenzene, then second, which is benzene with no groups, and the third, that is nitrobenzene with a nitro group, electron donating substituent. So the correct answer among the given option is option C,